You know that feeling when you're trying to get your head around something new, especially reading? It's
Hmm,
like the information's there, but your brain feels like it's juggling too many things, and some just drop.
definitely.
Today on the deep dive, we're tackling that. We're exploring how we actually process information, visual stuff like pictures, verbal stuff like words, particularly when learning to read.
And crucially, why some people find making those connections easier than others.
Yes, we're looking at how skilled readers and folks with learning disabilities handle both visual and verbal info.
Right. Think about seeing an apple picture and hearing the word apple. Ideally, your brain just links those seamlessly.
But sometimes it doesn't click quite right.
Exactly. We're diving into how those connections happen or, why they sometimes falter.
And to really get into the nuts and bolts, we're using a really interesting 1989 study. It's from the Educational Psychology Review by H. Lee Swanson.
It's a deep one. Looks at how our brains code images and words and how those systems interact, especially for reading development.
So our mission for this deep dive,
Well, it's understand the different ways skilled readers and those with learning disabilities integrate what they see and hear or read.
we want to shed light on the hurdles, maybe uncover some surprising efficiencies too.
Yeah, and we'll unpack a model from the study that honestly could shift how you think about learning and memory itself.
Okay, let's jump right in. A core idea. People with learning disabilities might have what the study calls functionally independent visual and verbal coding systems. In plain English, what's that mean for learning to read?
Think of it like two separate tracks in your mind. For LD readers, the visual track seeing a letter and the verbal track hearing its sound might not merge as smoothly.
So the bridge between seeing and hearing isn't as strong.
That's what the studies suggest, yeah. Difficulty building strong bridges between those processing routes.
And the impact of weak bridges. The research says it makes remembering visual stuff harder.
Precisely. Just
Like,
like the picture goes in one place, the word in another, and they don't quite team up effectively for recall.
hmm. So the verbal labels, the words don't give that extra boost to visual memory for LD
Right.
readers.
That's the hypothesis. The verbal code doesn't adequately enhance the visual recall. It's not providing that extra memory anchor.
Which is different for skilled readers, right? For them, a word can, like, flick a switch.
Exactly. It lights up a whole network. In other words, images, feelings, associations. It leads to richer semantic processing, much more efficient.
Okay, so the study proposes a three-stage model to explain this. Let's start with stage one. Modality-specific processing. What's happening initially?
So this first stage is where your brain makes an initial representation, specific to how it came in visual or verbal, like a snapshot or a recording.
Okay.
And interestingly, for nonverbal things like abstract shapes with no obvious name, this initial processing seemed pretty similar between LD and non-LD readers.
So we all see a new shape initially in much the same way.
That's the suggestion. The study cites research, Valutino and others looking at visual capacity, discrimination, visual memory, and across many nonverbal visual tasks, they didn't find huge differences.
Okay, so if we're all seeing things similarly at first, where does the difference kick in?
It really seems to hinge on that verbal coding, how we use words to make sense of and remember things.
Ah.
This gets crucial with new or complex visuals, and especially when we attach names or labels. That's where skilled readers seem to leverage those verbal tags better.
That makes sense. If you can name it, you can remember it better.
Pretty much. It helps tame it in your memory, you could say.
So stage two, semantic processing. This is about meaning, right?
Yes, this is where the integration really happens. Visual and verbal info come together. Your brain looks for common properties, activating that semantic network, the web of meaning.
Going beyond just seeing or hearing to understanding what it is and how it relates to other knowledge.
Exactly. And they did some clever experiments, like a probe recall task where people learned fake names for unfamiliar shapes.
With relevant names sometimes and irrelevant ones other times.
Right. And what they found was really interesting. For skilled readers, just having a name helped recall whether it was relevant or not.
The label itself was a memory handle.
Seems like it. But for LD readers, name training sometimes didn't help, or even made recall worse.
Worse, that's the opposite of what you'd expect.
It is surprising, isn't it? It suggests that link between seeing and naming isn't as automatic or beneficial for them.
Wow.
There was another experiment, too, where kids drew nonsense shapes after different kinds of pre-training related words, unrelated words, or no words.
Then how did their drawings differ?
Skilled readers drew better when they had names and showed better superordinate organization, like grouping by category with related names.
Suggesting they prefer those general modal concepts?
Yes, representations not tied to just one sense. But the LD readers,
How did they do?
they actually drew the shapes more accurately when they hadn't been given names.
Really?
Yeah. It again points to difficulty blending visual and verbal info at that deeper semantic level. They seem to prefer sticking with just the visual.
Okay, that clarifies the semantic stage differences. Now, stage 3, lexical processing, the naming system.
Right. This is your brain accessing the lexicon for what you see, finding the right label, which then feeds into that semantic network.
Like seeing a cat, retrieving the word cat, which then unlocks all your cat knowledge.
Exactly. And to dig into this, they subdivided the LD readers based on vocabulary size, high versus low lexical ability.
And how did that affect performance on the name training tasks?
This is where it gets really key for understanding learning. The LD readers with higher vocabulary skills actually benefited from naming, like the skilled readers.
Ah,
But the LD readers with lower vocabulary still did better when the shapes were unnamed.
wow. So vocabulary strength is critical for linking visual and verbal info. It's not just the LD label itself.
Precisely. Vocabulary isn't just a list, it's a bridge. A richer vocabulary provides more anchors in that semantic web.
Okay. The study also looked at memory short-term versus long-term. What emerged there?
They used some analyses, drawing on memory research. It suggested LD individuals might have more trouble coordinating semantic resources between short-term working memory and long-term storage.
So not just getting info in, but moving it from temporary holding to permanent knowledge.
Right. And this difficulty seemed more pronounced with easily labeled items, high-codable ones, and after name training.
Like the naming itself created a bottleneck for the LD group.
Potentially, yes. Disrupting that flow from short-term to long-term.
They also talked about availability versus accessibility in memory. Can you unpack that?
Yeah, crucial distinction. Availability. Is the memory trace even there? Accessibility. Can you actually retrieve it? Like a book in the library, it might be there, available,
Yeah.
but lost, inaccessible.
Okay.
They used a two-probe queuing method to try and separate these, give one hint that may be a stronger one.
And what did that reveal?
When they accounted for accessibility, the skilled reader's advantage with named items was mainly seen early in a sequence. This hints that the recall difference, especially involving semantics and labels, might be more about the retrieval process for LD readers, not just storage. The info might be there, but harder to get out using a verbal cue.
Subtle, but important. What about actual text processing? They used lexical decision tasks, synonyms, homophones.
Right. Those experiments reinforced the semantic processing difference. LD readers struggled more when meaning was key, like with synonyms.
But less difference with surface-level stuff like repeated words.
Exactly. Performance was more comparable then. And the homophone experiment was interesting.
How so?
It suggested skilled readers might sometimes over-rely on semantics, getting confused by words that sound alike but mean different things in sentence verification tasks.
Huh. So a strength can sometimes trip you up.
In very specific contexts, yeah. Their strong expectation for meaning can backfire slightly.
Fascinating. They also touched on neuropsychology, dichotic listening tasks.
Yeah, briefly. Those tasks hinted that skilled readers might better link resources between brain hemispheres, potentially using semantic properties as a bridge.
So integrating info across the brain may be facilitated by meaning more effectively in skilled readers.
That's the implication. So, pulling it all together, what are the main conclusions?
What's the big picture?
Well, the study concludes that LD individuals often struggle with the additive effect of multiple inputs. Visual plus verbal doesn't always help, might even hinder recall.
But crucially,
Their visual coding itself seems largely okay. Skilled readers are just more flexible, using both specific visual-verbal codes and those integrated amodal meaning-based ones.
so it's less about seeing clearly, more about how visual interacts with verbal reinforcement.
That seems to be a key takeaway, yes, which leads to theories about why. One is about verbal codability.
Right.
A study suggests the recall difference isn't just about items being easy or hard to name, but more about coordinating semantic resources between memory stores.
And processing visual form versus meaning.
It hints LD readers might process these more separately, maybe favoring the visual, while skilled readers integrate them better.
And dual coding versus amodal coding, separate bins or one meaning bin.
The findings lean towards skilled readers using both flexibly, while LD readers rely more on the modality-specific, especially visual, system.
Did they look at alternative ideas like
Yeah.
reductive coding or rehearsal issues?
Briefly, Reductive coding suggests maybe a less efficient route from visual to semantic for LD readers.
Okay.
And while they can form associations, that higher-level semantic organization grouping by meaning seems tougher for them.
And the interactive compensatory model.
That fits well. It suggests if you're weaker in one area, like verbal coding, you might over-rely on a stronger one, like visual coding. The findings here seem to support that possibility for LD readers.
So wrapping it all up, the core issue might be
The study points towards a potentially less efficient lexical system vocabulary and word knowledge as a key factor. If that system isn't effectively feeding into the semantic system, it hampers flexible coding and makes linking sight and language-based understanding harder.
Okay, let's bring this back to the listener. Key aha moments from this deep dive.
I think one huge one is just how vital linking visual and verbal is for learning. It's not just seeing or hearing, it's the brain actively connecting them for meaning.
Right.
Also, the idea that visual processing itself can be a strength for LD individuals is really important.
Yeah.
And finally, the huge impact of vocabulary. Building word knowledge isn't just knowing more words, it strengthens how your brain connects all information.
So a final thought for everyone listening. Think about how this applies beyond reading, learning any new skill or subject. How might knowing about these different processing styles change how we teach or how you learn? Could focusing on building semantic connections, the why behind the what, unlock things?
It's definitely food for thought. We encourage you to reflect on your own learning, maybe explore dual coding or semantic processing more. Understanding these cognitive gears can really empower learners and educators.